right. Hello, everyone. Good afternoon, and welcome to Demystifying OAuth2 login flows. And my name is Laurel Bellman. I'll be moderating this session. I'll begin by briefly introducing our speaker, David Schultz, followed by his presentation, and then we'll have some time at the end for Q&A. Please note that we are recording this presentation and an accessible video will be available for viewing on the IT Professionals Conference website next week. So David Schultz, as you might have heard, is with IceCube. And actually, you can probably talk more about IceCube than I can and your role within it. So maybe I will let you do that. We will be taking a few questions at the end if there is time. So please feel free to put any questions in the chat if you have them, and I will make sure to read those out to David. All right, I think I'm going to turn it over to you now, David. So let's find out about OAuth2 login flows.
Okay. I'm David Schultz. I work at IceCube or WIPAC as it's known on campus. I've worked there for 12 or 13 years now, and I'm a manager that does a variety of things with the group there, but it's software and systems based. One of the projects that I've been working on lately has been OAuth and authentication and things like that. So I figured I could give a talk about it. So here, I just have a basic presentation about OAuth and what that is. And I'm going for the more simplistic view here of if you're more of a client of OAuth, you're just trying to use the API and you're not really trying to set up everything yourself. What would that look like? So first, what is OAuth2? Where is it used? Then go through the four major login flows and a couple of tips and tricks at the end based upon my experience. So first, there's a nice RFC that you can read on OAuth2, but in simpler language, it's around how a user can grant resource access to an application via an interaction with an authorization server. And you don't necessarily have to reveal credentials or identity to the application. They can actually be independent. You can also revoke this access and do other various things. And this is the primary RFC, but there's also, I don't know, like 10 other follow-on RFCs that for, they added various things or they constrained various things. One key point that I want to make is that in general, the application does not directly handle credentials. Instead, the HTTP connection is redirected to the authorization server, and the authorization server handles the credentials, logs someone in, and then sends back an access token to the application. And this is how Facebook, Google, Microsoft, and all the other major social providers handle logins, both for their internal applications and for all the third-party applications that use those logins. One note about authentication versus authorization. OAuth2 is explicitly only defining the authorization part, but it's pretty common practice to add an authentication and identity management agent on top of this. And that's what you'll see just about everywhere. So tokens is the common thing that you hear about with OAuth. And once an application is authorized, it gets issued an access token. This has specific and very limited capabilities, such as you're allowed to read this file on this host, and it doesn't have anything to do with identity. The subject and the token can actually be a random identifier. So they're fairly limited and not they're very constrained in sort of the scope of what you can do. The access tokens are also very short-lived. They're only valid for on the order of minutes usually. And the idea is that you would keep asking for new access tokens as you needed them. There's also a refresh token concept if you needed a longer lived access, where the application can be issued a refresh token and it can use that refresh token to get new access tokens. Since we have SAML on campus, I wanted to say that one difference is that SAML uses browser cookies, which are not really well handled by API calls and non-website looking things. So it's if you just open, say, a Python application and you want to make calls via the web, cookie handling is problematic at best sometimes. So now we'll go over the flows of how OAuth2 works. There are 4 major flows or ways to get access tokens. They're sometimes also called grant types. There's the client credentials grant, which is mostly for backend service accounts. The authorization code, which is normal websites and web apps. The device authorization, which is the Internet of Things and other situations outside of a browser. And the resource owner, which is for trusted non-browser applications, more traditional applications, and not particularly recommended anymore. Starting with client credentials, this is strictly machine-to-machine communication. There are no users involved, and it's usually backend services of some type. And so it's, say you had a service account that wanted to talk to some sort of resource. This is basically what it would use. It basically doesn't know anything about users. It just wants its own account. In this case, the application registers itself as a private client to the authorization server, and it's given a client ID and a client secret. The request flow is down at the bottom. It's pretty simple. The app requests an access token using the ID and the secret. The authorization server validates those and returns an access token, and then the app can use that access token to interact with the resource or service. The authorization code is more of the normal flow that you would think of for web applications and the one that you'll see all over the web. The application gets registered with your authorization server, and it can be public or private, depending upon if it can store the client secrets securely. Some web apps are completely in the browser and they can't actually store a client secret, so they would be public. For the private request flow, we have 6 different steps here. I'll put in a nice diagram here because it starts to get fairly complex. But the user first clicks on an application's login link and they get redirected to the authorization server. On the authorization server, they can log in, they can approve the application, because usually the authorization server will say, this application so-and-so is requesting access to this, and you can say yes or no. Then if that gets approved, it gets redirected back to the app with an authorization code. After that, the application receives that code. It can contact the authorization server directly and exchange that code for an actual token. That's one thing is that the authorization server has to validate the code and the client ID match the initial request. Beyond that, once the application gets the token, it can actually use that to talk to the resource or service. For one extension to this, if you're using the public clients, there's a mode called proof key for code exchange. And this adds a random code challenge to the authorization server redirection. and a matching verifier when exchanging the code for a token. This mostly is for if the authorization code is intercepted, it cannot be directly exchanged for a token without the verifier. And this is mostly meant to deal with malicious phone applications, which could potentially intercept URLs for other applications. It was an interesting case that came up where people actually found applications doing this in the wild, and so they made this extra secure mode just for that. The next flow is device authorization, which is it was primarily meant for Internet of Things devices, but it also works really good for things that lack a web browser inside of them. And it's the authorization registers again, and it can be public or private. And then for this one, it looks sort of similar to the previous one, except it's slightly different. So an application requests a device code from the authorization server first. When it has this device code and a user code that are returned, it presents the user code and the author URL to the user. The user is then expected to log in and approve the application. Meanwhile, the application actually polls the authorization server and waits for approval, whether that the user has actually approved the application or whether they have not. And once approved, then it will return the access token, and the application can use it to talk to the resources. The final flow that I'll be talking about is the resource owner. This is the traditional application login, playing man in the middle with the user credentials. And in this case, the app must be trusted with full access to anything the user can do, because the app is basically the user in this case. They have your full credentials. This is not recommended for any new applications simply because of this large security trust that you have to give. And in this case, the application does not need to be registered because it directly uses the user credentials. And the request flow is fairly simple. The user enters their credentials in the application's login form. The username and password are sent from the application to the authorization server. The authorization server validates these and returns the token. And the application then uses this to interact with the resource or server. And so you can see here that the user never logs in directly to the authorization server. They log in through the application. Now for a couple of tips and tricks. The first one, if possible, use existing code. Most languages have at least one client library where someone else has already figured this out. Some languages have up to 10 different libraries because the language is popular and people have done a lot of these. This will probably save you weeks of time and several subtle bugs, since you don't need to know the low-level details. And even, some libraries don't have everything, but they have enough stub code that you can get most of the way there without doing everything yourself. If you want to actually run your own authorization server or provider, definitely use an existing one and don't do it yourself. We at IceCube use Keycloak, which is backed by Red Hat and IBM. And there are also several open source and commercial offerings for this. The second tip I have is if you have a command line application, use the device authorization flow. This actually makes it really easy to do various things in the terminal, because it's as an example on the right I have here, where you can present the link that the user can click on to open in the browser. This is much easier than trying to launch a browser inside your application, especially if this is on a remote machine where it may not have a browser at all. You can also present a QR code if you want to make logging in via phone, and also just because ASCII graphics are fun and you can do this. And so this is something that I found to be especially useful because we do a lot of command line applications. It makes it significantly easier to just click the link, enter the code, and then the application is logged in. So any sort of questions?
Anything for David? Well, I'm sure David would be more than happy to connect with you afterward. Thank you for putting up those diagrams, David. Those are really helpful as you went through your login flows.
Yep.
All right. Well, thank you very much for sharing this with all of us, and I will let everyone get on to some other sessions. Thanks, David.